Okay, so welcome to another video. Last time we started talking about functions and we did tasks 1, 2, 3, or 1, 2, 3, yeah. So today we will cover three next tasks from this list. And to be honest, it's been quite a fun time to work with it, because I knew lots of new things. Well, first of all, let's talk about our task number 4. We need to find a function decorator for measuring time of performance. So I've been playing around with those decorators just so that I fully understand and grasp how they work. Like this, you should even see it. So that is number 4. Right. Okay. Okay. Everything should work. Okay. So, for this, we would really like to input time module. Or you can find another option with data module, but then the syntaxes will be a little bit different. So it really depends on your necessities and on your preferences mostly. So, I'll talk about it a little bit later. What is a decorator? A decorator is an additional function that allows you to add some actions before and after any of function wrapped with it perform, right? So our basic task over here is to make a decorator to measure the time that our main functions is going to work is going to consume for the performance. So what are we doing? We make a simple function, but within it we make a new function called wrapper. So our time measure function has an argument which is going to be func. It's basically like just a normal name of a variable, and this is going to be our main function we are going to wrap. Then we make another function def wrapper, which is going to take exactly the same arguments that our wrapped function takes, right? And mostly often people use something like star arc star works, so that the decorator works with all the functions, taking all the possible arguments. But in this case, even this is a little bit too much, as our we will try it in our FIBA2 function, which only takes one argument, so you can even avoid this star over here, so that your inner function can take just one argument. And what do? We make up a first variable that's going to be the time of the starting process, right? You can get it with using these syntaxes. That's why we need the module time. So we type the name of the module, then we type the function we're going to call, and yes, that's a function built in the module time. Then we let our function work with all the necessary arguments. Then we make up a new t2 variable that's gonna mark the end of the performance of our main function, as it is called right after that, right? And then we print, we just display our time that our function needed, and we return wrapper over here. So make sure that you understand that you return wrapper, this function. The name can be different, of course, but it's some kind of a conventional thing. and most developers just call this inner function wrapper. Okay, and how to use it. You can you just place at name of the decorator before define your function. After that, you call your function normally, and that's it. I will just comment everything after that, right? So it doesn't mess our output. And you see, we have only one decorator, like here, time measure. Let's try that. So this is the result of our function. I altered it a little bit, so it now displays only the last element of the Fibonacci sequence, limited with our n, right? And now you can see how much time did it take it to count the whole this Fibonacci list. Now, you can also add lots of different decorators for each function if you need it. For example, just to train, I added a validator decorator. The structure is completely the same. The only thing we alter is the inner part of our wrapper function. So if the type of an argument is integer, I know it could be like you can take typing module. From this typing module, you can take integer data type and place it here. But no, the type of one is integer. So if the type of an argument is integer, then we do the function. Else we print that it's a wrong type of an argument. Okay, hope so. Now let's check this decorator. We uncomment it, and as you see, it lets our function to perform as here the argument is integer. But if I'd say I would like it like this, wrong type of the argument, because it's float. We don't want float over here. Then just a fun logger decorator that's gonna print that the function was called and print that the function has finished its work. It doesn't really do anything meaningful at all, but as you can see, you can hang even 3 decorators over one function and it's still gonna work. So the function was called, the result of the function, time, and the function has finished its work. As you can see, everything works perfectly fine. Now, we did it. Now, when it comes to our task number 5, we need to make up a function for working with nested lists. Okay. To be honest, I don't really understand what does it mean to work with nested functions. But I decided that it's going to be a function, the recursive function, a new type of that, which is going to print out the elements of the list depending on in which nesting level this element is. So if it is in the primary list, it's gonna be printed just. Otherwise, it would be printed if it is the second level, for example, right? So it's gonna be with 1 dash. And level 3 is gonna be with 3 dash and so on. So the more wraps are there on the element, the more dashes there will be placed before the element. And how can we do that? We can do a function that's going to take our list, and we have a named default parameter nesting, or nesting level, you call it whatever. And we set it by default as 0. Then we start a cycle, and for each element we check. If it is not a list, then we print it just as I said. So how many nestings were there before? We multiply to our separator, and we add our element in a string format. Else, but what if it is a list? What if it is a list? If it is so, right inside of this function, we call it one more time. Okay? But in this case, we call it not for a list, for our initial list, but for an element of the original list we have faced with the nesting parameter added 1. By default it's 0. In here it's 0. In the next level it's gonna be 1. In the next level it's gonna be 2, and so on. So we have this list. Let's try that. As you can see, the element one, the level 1 has no dashes. Level 2, 1 dash. Level 3, 2 dashes. Level 4, 3 dashes. Level 5, 4 dashes. And as you can see, it kind of reminds the basic structure of like, you know, that page in a book where all the chapters are, and if you're familiar with some scientific articles, you have some sort of like those nested lists where it's paragraph 1, paragraph 1.1, paragraph 1.1.3. You know, that's basically the same thing. Actually, we can even display here not just a dash. We can do here like literally there all those numbers. You can just modify this function to do so. So this is kind of fascinating as well. That's a recursive, and to be honest, it is pretty complicated to understand. You definitely want to take your time and play with the recursion functions so that you truly grasp the principles of work, because yeah, it's pretty complicated from the logical perspective, not from the programming perspective. As you've seen, it's one of the shortest functions at all. Okay, now we get to our task number 6. Task number 6 says make up a function for validation of email address. You can use different approaches in here. I didn't want to make it too complicated, so I just will check if this kind of if the email has this @ symbol, and if it is followed by one of these domains which I'm aware about. So basically, what does it do? If the type is string, first of all, right? Because if we are provided with just a number, we don't want to mess with it. And there is @ in this input in this variable, and the last element of this, when we split it by @, so this part, is something in this list, then we say that this email is confirmed. Otherwise, we treat it as an invalid address. So you can run this program and you can see the first one, software.gmail.com, is a confirmed email. ASDL at asdka.asd is an invalid address because of course it is a string, and of course it is an at in it, but the part that follows the at is nothing, is not one of the elements of this list. We don't have this in this list. This is what this part checks. Yeah, and of course this is an invalid address as well, because it's just some random letters. So we have 4 tasks to do. I'm not really sure, but I will try to do it on Friday, I guess, as I will have some free time, hopefully, that day. So that we will try working with tasks 7 to 10. This is the point when it starts to be really interesting, but a little bit complicated, sometimes even tricky. But anyway, it's kind of cool, I should say, really. For example, recursive functions are very well used when working with graphs, for example. And we can really, now we can type some functions that would be really useful on this planet. So thank you very much for watching this video. Hopefully we will finish working with functions this week, and we'll go to classes and objects, which is a very interesting topic as well. And after that, I guess that we will have some real tasks, right? So we will be able to work with Telegram and Discord to make real bots. Fortunately, maybe not. Who knows? I may find it out, but I won't. So, thank you very much, and always remember, even if you're a dabbler, and even if you feel like you can do nothing, and even if you feel like you know nothing, educate yourself. Do a bit, but every day. Keep pushing, whatever it looks like, and everything will come. So, with this being said, thank you very much for watching my videos. I do really appreciate that. I also appreciate comments under my videos so that I can find out what I can improve. And just start believing in you and work a little bit, but every day. Thank you so much. Have a nice day. See you in the next video.